You're here because you want to get smart fast on important topics. Today, well, that topic is fire technology and safety management.
That's right.
We've got a fascinating curriculum here, a diploma in fire technology and safety management. Think of it as the essential knowledge base, really, for keeping people and places safe from fire.
Exactly. And it's so much more than just, putting out flames. This diploma, it dives deep into everything.
Like what specifically?
Well, from how you build a safety-first culture in a workplace to the really intricate engineering of fire suppression systems.
Okay.
Then there are the specific challenges you find in industrial environments, the actual core science of fire itself, which is fascinating.
Yeah.
And of course, the hands-on skills,
Mm.
the practical stuff you absolutely need in an emergency. It's a really comprehensive field.
It sounds it. And our goal in this deep dive is to pull out those really crucial insights, maybe those aha
Yeah.
moments. The things that give you a real understanding of what this diploma covers and, importantly, why it matters so much. We're going to look at why just having safety rules isn't enough.
Definitely not.
The maybe surprising ways different materials react to fire and what it really takes to handle a crisis effectively. Okay, ready to jump in?
Let's do it. Where should we start?
Let's start right at the top, safety management.
Okay. So, safety management. Fundamentally, it's about building a system. It's not just, a binder full of rules.
A system, right?
Yeah, the curriculum emphasizes these key elements. First, you absolutely need a policy and commitment. Leadership has to be visibly on board.
Okay, top-down buy-in.
Crucial.
Yeah,
Then comes planning, figuring out what actually needs to be done, how are you going to do it.
right.
Next is implementation and operation plan.
Mm.
Putting those plans into action day to day.
Making it real.
Exactly. After that, measuring performance, you have to see if what you're doing is actually working. Are the numbers going the right way?
Makes sense. Metrics.
And finally, auditing and reviewing performance. Because safety isn't static.
Right.
It's all about constant improvement. You have to keep checking and tweaking.
That idea of a constant loop, that makes a lot of sense. It's definitely not a set it and forget it kind of thing.
Not at all.
And the safety and health policy itself, that's the bedrock, the foundation of all that, isn't it? It's got to be more than just like words on paper.
Oh, absolutely. Developing that policy, it involves setting really clear objectives and targets.
Yeah.
Measurable ones.
Right.
This gives the whole organization a kind of roadmap for its safety efforts. Everyone knows the goal.
And it's not just the bosses who are responsible, is it? I mean, the diploma seems to emphasize that everyone in an organization has a part to play.
Precisely. Yeah, it breaks down the roles and responsibilities at every single level, from the very top of management right down to each individual employee.
Everyone's got a stake.
They do. And a key part of that is safety consultation, actually getting input from the people doing the work every day.
Ah, okay. Why is that so important?
Because they often see the hazards, the little things, that maybe management or even a safety officer might miss from their perspective.
Which makes perfect sense, doesn't it? The people on the front lines, they just have that unique perspective.
Exactly.
Now, how does the diploma address making sure everyone actually has the right skills and, the knowledge they need?
Right. That's where training, awareness, and competence come in. Huge area.
I bet.
The curriculum stresses how important it is to figure out what training is needed. And that's at the organizational level, company-wide stuff for specific jobs, because different roles have different risks.
Sure.
And sometimes even for individual employees who might need something specific.
Okay.
But, and this is key, it's not just about delivering the training. It's about evaluating how effective it was. Did people actually learn? Did behavior change?
Ah, the follow-through.
Exactly. And getting feedback so the training itself can be improved. It's like a feedback loop just for skills development.
Targeted training that actually works.
Oh,
Yeah, that's
okay.
crucial. Now, the word risk, it's obviously central to safety. How does this diploma tackle that complex issue of risk?
Risk assessment and control. Yeah, they're a cornerstone of the whole thing.
Right.
The curriculum outlines the legal reasons why it's so critical, but also the essential steps. First, you've got to identify the hazards, what could go wrong.
Okay, step one.
Then, you assess the level of risk those hazards pose. How likely is it? How bad could it be?
Likelihood versus severity.
Exactly. And finally, you determine what actions need to be taken to control those risks. How do we eliminate it, or reduce it, or protect against it?
Got it.
And it really highlights the need for properly trained professionals to conduct these assessments. It's not something you just guess at.
No.
And the importance of keeping good records. documentation is vital.
What's like a surprising thing about risk assessment that comes up?
Well, what's often fascinating is that sometimes seemingly small, often overlooked hazards, the trip hazard, the frayed wire,
Hmm.
can sometimes carry surprisingly high risks when you actually analyze them properly. It's not always the big obvious stuff.
Right. It's not always the, giant chemical tank that gets you. It could be the poorly stacked boxes.
Precisely.
And the diploma also touches on things like employee motivation and even insurance. How do they fit into the safety picture?
Well, employee motivation it's crucial
Mm.
because a motivated workforce, one that feels valued and heard,
Yeah.
is just much more likely to follow safety procedures, to report potential problems, to actively participate,
Okay, engagement matters.
usually.
Yeah.
And insurance, well, it doesn't directly prevent accidents, obviously,
No, right.
but it plays a really vital role in mitigating the financial impact if something does happen. It allows businesses to recover, maybe reinvest in better safety measures.
Yeah.
It's part of the sort of broader resilience of an organization.
Interesting. Insurance is a safety net in more ways than one then.
You could say that, yeah.
What about the facilities themselves? I mean, buildings age, processes change.
Good point.
Right.
The curriculum definitely considers the entire life cycle of a plant or facility
Yay.
and how unsafe conditions can develop over time, as things age, equipment wears out, maybe processes are modified without fully considering the safety impact.
Creeping risk.
Kind of, yeah.
Mm-hmm.
It emphasizes the vital role of regular planned maintenance in preventing accidents, not just fixing things when they break, but preventative stuff.
Proactive, not reactive.
Exactly.
Uh-huh.
And the necessity of having a dedicated safety department, or at least clear safety responsibilities, to oversee all these ongoing efforts.
So safety isn't a one-time project like installing a machine. It's something you have to constantly work at, manage actively.
Constantly. It's woven into the fabric of operations.
And it's not just the company's responsibility stuck within the factory gates, is it?
Oh, not at all.
Yeah.
The diploma really broadens that view. It includes the safety responsibilities of management, obviously, but also considers the public, government agencies setting regulations, social organizations advocating for safety, and even international bodies like the ILO, the International Labour Organization.
Wow.
It's a truly shared responsibility when you look at the big picture. Global standards, local implementation.
Okay, that's a great overview of safety management. Let's move into something maybe more tangible. Fire protection system and design. This sounds like where the real hardware and engineering come in.
Exactly. This section gets into the nuts and bolts. It starts with the things we all recognize, right? Fire extinguishing appliances, those portable extinguishers you see everywhere.
The red cans.
Yeah, those. It covers not just selecting the right type for the potential hazard water, foam, powder, CO2,
Uh-huh.
but also their proper installation, where they should be located, and crucially, their regular maintenance and inspection.
Ah, maintenance again.
It's a constant theme. A surprising number of extinguishers fail in an emergency simply because they haven't been checked regularly. They lose pressure, nozzles get clogged.
So having them isn't enough. They need to be ready to go, functional.
Absolutely ready. Then the curriculum moves on to the bigger stuff. Things like mechanically driven fire engines and trailer pumps.
Right, the heavy hitters.
Yeah. And then fixed systems like hydrants. This covers everything from the pumps that supply the water, the fuel for those pumps, fixed monitors, those big nozzles you see at industrial sites, the hoses, the different types of nozzles for different applications, and again, the absolute necessity of ongoing maintenance to ensure they work when you need them most.
You don't often stop and think about the sheer amount of infrastructure that goes into just being prepared for a potential fire, do you?
It's immense
Mm-hmm.
and often invisible until it's needed.
And then we have sprinkler systems, which are probably the most common automatic system people think of, almost invisible until they activate.
Right. The diploma covers their detailed installation requirements, the complex network of piping and fittings hidden in the ceiling, the pressure gauges, the control valves that isolate sections, and, you guessed it,
Maintenance.
maintenance. What's particularly interesting here is how the requirements change based on the building's use.
How so?
Well, buildings are classified by occupancy. Think a hospital versus an office block versus a warehouse.
Okay.
Each has very specific sprinkler design requirement based on the expected fire load and the risk to occupants. And then there's the vital role of static water storage tanks, ensuring there's enough water on site if the main supply isn't sufficient.
So building design and fire safety are just completely intertwined from the start.
Inextricably linked.
Yeah.
And I imagine blueprints and diagrams are essential for managing all of this complexity.
Oh, absolutely. The curriculum includes specific instruction on preparing fire protection plans and, crucially, understanding the standard signs and symbols used on those drawings. You need to be able to read the plan. Right, a common language. Okay, all of this so far is about suppressing fires, stopping them from getting out of control. But what about detecting them in the first place? That's where fire alarm systems come in, right?
Correct. Detection is the critical first step in many cases. This part of the diploma covers the fundamental principles behind automatic fire detection,
Uh-huh.
the different types of systems available, conventional, addressable, etc., and the classification of different detectors.
Detectors, like smoke detectors.
Exactly. And what's fascinating is the science behind how different smoke detectors work. You have optical detectors, sometimes called photoelectric, that basically see the smoke particles scattering light.
Okay.
And then you have ionization detectors, which use a tiny radioactive source to sense changes in ion flow caused by smoke particles,
Hmm.
though these are becoming less common in some areas. There are also radiation-based detectors that sense the infrared or ultraviolet light emitted by flames.
Oh.
Each type is better suited for different kinds of fires and different environments. For example, a smoky, smoldering fire might be picked up faster by an optical detector, while a clean, burning, flaming fire might trigger a radiation detector more quickly.
That's a level of detail I hadn't really considered, so it's definitely not a one-size-fits-all approach to detection.
Not at all. You need the right detector for the anticipated risk. The curriculum also covers things like linear heat detectors.
What are those?
They're like a cable that can sense a temperature change anywhere along its length. Great for tunnels, conveyors, large open areas,
Oh, okay.
and even radio-based detection systems for places where running wires is difficult or impossible.
Right,
Then it really delves into the electrical engineering side.
right.
Automatic fire detection circuits, both open and closed circuit types, the specific detector circuits and alarm circuits, the critical wiring standards, and ensuring you have reliable power supplies, often with battery backup.
So it's basically a whole dedicated, highly reliable electrical system with one single critical purpose.
That's a good way to put it. And the control panel is the kind of central hub, the brain
Yeah.
of that system. Precisely. The diploma covers the general aspects of these control and indicating equipment panels,
Mm-hmm.
how they divide a building into zones for easier location,
Mm-hmm.
how they manage the power supplies, indicate faults if something's wrong with the system.
Important.
Critical, yeah. How they handle monitoring and maintenance alerts, display information visually, provide specific event location messages, fire detected, zone 3, first floor, and even how they can connect to remote monitoring centers, like the fire department or a security company.
So help can be dispatched automatically.
In many cases, yes.
Yeah.
It also covers the really important strategic positioning of detectors. You can't just stick them anywhere. And, of course, the importance of manually operated fire alarm call points. The classic break glass boxes.
It's like a brain with nerves extending throughout the entire building. The diploma even touches on real-world incidents to illustrate these points, doesn't it?
It does mention using case studies, particularly fire hazards in India, to illustrate key principles and lessons learned, although the overview we have doesn't detail specific cases.
Right.
But importantly, it really emphasizes the practical application of all this knowledge. Things like conducting hydrant fire drills, actually visiting buildings with different sprinkler systems installed.
Seeing it in action.
Exactly. Studying real fire protection plans, conducting emergency evacuation drills, getting people out safely, and getting hands-on experience with different types of detectors and sprinklers. Touching and feeling the equipment.
That practical element must be absolutely essential for truly understanding how these complex systems function, especially under the pressure of a real emergency.
It makes all the difference. Theory is one thing, application is another.
Okay, now let's move on to industrial safety. I imagine this area has its own unique set of challenges compared to, say, an office building.
Oh, definitely. Industrial safety focuses specifically on the hazards and safety protocols within various types of industries. Think manufacturing plants, chemical processing facilities, construction sites, mines.
Very diverse.
Hugely diverse. It covers the fundamental safety systems and equipment used in these environments, the importance of having a tailored safety policy for that specific industry and site, and the specific terminology you need to know. What's really key here is that the level and type of hazard can vary dramatically.
Right, so a safety plan for, I don't know, a food processing factory will look totally different from one for an oil refinery.
Completely different risks, different controls needed, absolutely.
So what are some of the key tools and processes used in industrial safety management that the diploma highlights?
It highlights several critical tools, things like work permit systems.
What's that exactly?
It's a formal system to control high-risk activities like hot work, confined space entry, working at height. It requires written authorization before the work can begin, ensuring all precautions are in place.
A documented check? Makes sense.
Yeah. Then there's job safety analysis, or JSA. This breaks down a specific task into steps to identify potential hazards at each stage and figure out how to mitigate them.
Proactive, step by step.
Very much so. It also covers more advanced techniques like HAZOP study, that stands for Hazard and Operability Study. It's a very systematic, team-based way to scrutinize a process or designed to identify the potential hazards and operational issues.
Okay, sounds intensive.
It can be, but it's incredibly valuable for complex processes. And fault tree analysis, which is more of a top-down deductive approach. You start with an undesirable event, like an explosion, and work backwards to figure out all the possible contributing failures or conditions.
These sound like really structured, very proactive ways of identifying and mitigating potential dangers before they lead to accidents.
That's the goal. Prevention is always better than cure.
And if something does happen, despite best efforts, there needs to be a plan in place, right?
Absolutely. Emergency planning is a crucial component. Knowing what to do, who does what, evacuation routes, communication, along with things like safety inventory systems, keeping track of hazardous materials, maybe using safety data sheets, conducting regular risk assessment surveys to keep tabs on potential hazards.
Managing the known risks.
Exactly. The curriculum also specifically addresses occupational health hazards. These are often the longer-term risks from exposure to certain chemicals, noise, dust, ergonomic issues.
The slow burn hazards.
Yeah, things that might not cause an immediate accident but can lead to serious health problems down the line. And it details the specific role and responsibilities of a dedicated safety officer in an industrial setting.
So there's usually a dedicated professional or team overseeing safety in these often complex, high-risk environments.
Often, yes, or at least someone with clearly defined safety responsibilities.
Mm-hmm.
And the ultimate goal, of course, is always prevention.
Right.
So the diploma covers various accident prevention methods, the important role of safety committees getting workers involved in safety discussions and decisions.
Fostering that culture again.
Exactly. And the detailed processes for accident investigation, if, unfortunately, something does occur. Learning from mistakes is critical.
So you don't repeat them.
Precisely. It also touches on comprehensive safety management systems, like ISO 45001, and the relevant legal framework, the laws and regulations that set minimum safety standards. Things like the Factories Act, Explosives Act, Electricity Act, depending on the country and industry.
Okay, so a really strong foundation in both the practical aspects of industrial safety and the legal requirements you have to meet. Let's shift gears slightly to fire engineering science. This sounds like the scientific backbone of, well, pretty much everything we've discussed so far.
It really is. This section lays that fundamental groundwork. It actually starts with a brief history of the fire service, which gives some interesting context.
Okay.
And then it dives right into essential physics, covering units of measurement, concepts like force, motion, mass, weight, work, power, energy.
Back to school physics.
A bit, but it's applied physics. Understanding conservation of energy, the basic mechanics of rest and motion, distance, displacement, speed, velocity, acceleration, gravity, Newton's laws.
Why is all that important for fire?
Well, think about pumping water, the force needed, the pressure, how water moves through hoses, that's fluid dynamics, based on these principles. Or understanding how structures might collapse under heat stress. It also touches on simple machines, their efficiency, and crucially, friction loss.
Friction loss.
Yeah, when water flows through hoses or pipes, you lose pressure due to friction. You have to account for that in calculations for firefighting. These principles are absolutely crucial for understanding how all the firefighting equipment actually works.
So the basic laws of physics are surprisingly relevant, even fundamental to fighting fires effectively.
Absolutely. And then comes the essential chemistry of fire, which, as you can imagine, is absolutely critical.
Exactly.
This part of the curriculum covers things like atomic structure, elements, compounds, mixtures.
Basic chemistry.
Right. The difference between physical changes, like melting ice, and chemical changes, like burning wood. The energy changes that happen during these reactions, how heat affects different types of matter, solids, liquids, gases. It explains the process of combustion itself, what's actually happening at a molecular level when something burns. Plus, concepts like temperature, specific heat, the role of catalysts, neutralization reactions, sublimation, where a solid turns directly into a gas.
Like dry ice?
Exactly. heat of decomposition,
Mhm.
different types of chemical reactions, especially exothermic reactions that release heat, which is what fire does, and endothermic ones that absorb heat. What's really interesting is how seemingly similar materials can have vastly different combustion properties based on their chemical makeup.
That's a lot of fundamental science underpinning something we see maybe almost every day but don't think about at that level. And it also covers how heat actually moves, right? That seems key for fire spread.
Yes, absolutely crucial. It explains the three main ways heat is transmitted. Conduction heat moving through a solid material.
Like a metal poker in a fire.
Perfect example. Convection heat transfer through the movement of fluids, liquids, or gases.
Like hot air rising.
Exactly, carrying the heat upwards. And radiation heat traveling as electromagnetic waves, like the
Mm.
heat you feel from the sun or from a fire without touching it.
Okay.
It also covers really crucial fire-related concepts like flash point.
What's that again?
It's the lowest temperature at which a liquid gives off enough vapor to form an ignitable mixture with air near its surface. It'll flash, but might not keep burning.
Okay.
Then there's fire point, which is usually slightly higher. That's the temperature where it will produce enough vapor to sustain burning.
Ah, the difference is sustained burning.
Right. And ignition temperature, sometimes called auto-ignition temperature. That's the minimum temperature a substance needs to reach to ignite without an external spark or flame.
It just bursts into flame on its own if it gets hot enough.
Basically, yes. And it clarifies the key differences between flammable materials, which ignite easily at lower temperatures, and combustible materials, which need higher temperatures to ignite.
Important distinctions.
Very. It also explains phenomena like spontaneous combustion, where something self-heats to its ignition temperature, the classic fire triangle fuels, oxygen, heat, and the more complete fire tetrahedron, which adds the chemical chain reaction element. Breaking that chain is how some extinguishing agents work. And finally, the various ways fire can spread directly by flame contact or via conduction, convection, and radiation.
Those visual aids like the fire triangle and tetrahedron, they really help solidify those core concepts, don't they?
They do. They're simple but powerful tools for understanding the basics. Now, what about the actual methods of fighting fire using, say, water-based systems, the fixed installations?
Right.
This section covers those fixed firefighting installations that use water as the primary extinguishing agent. Things like different classifications of hydrant systems, wet barrel, dry barrel, depending on climate. Various types of sprinkler systems, which we touched on earlier, but here maybe more detail on the science.
Oh.
Major foam pourer systems, often used in large industrial settings like tank farms.
For flammable liquids.
Exactly. Steam drenching systems for specific enclosed hazards, and the principle of emulsification, where water is used to break down certain flammable liquids into a non-flammable mixture.
Interesting techniques.
Yeah. It then specifically addresses the unique challenges and firefighting techniques required for what it calls special fires, specifically mentioning aircraft and ship fires.
Right. I can imagine fighting a fire deep inside a ship or on an aircraft presents a completely different set of logistical and technical hurdles.
Confined spaces, limited access, stability issues, specific materials, huge challenges. And finally, this science section gets into classifying fires based on what is burning and the general approaches to extinguishing each type. It covers the standard classification of fires, Class A for ordinary combustibles like wood, paper, plastic, Class B for flammable liquids and gases, Class C for energized electrical equipment, Class D for combustible metals like magnesium or sodium.
Wow, didn't know that, Class D.
Yeah, require special agents. And Class K, or F in some regions, for cooking oils and fats. Knowing the class tells you what extinguisher to use, or crucially, what not to use. You don't put water on a Class C electrical fire, for instance.
Good point.
It also covers the common causes of fires, various detection methods again, and a range of extinguishing methods: cooling, smothering, starving, interrupting the chain reaction.
The theory behind putting it out.
Exactly. And it provides details on first aid firefighting equipment, the very first response, things like fire buckets, beaters for grass fires, hose reels, and then a deep dive into portable fire extinguishers, classifying them by weight, how they operate like pump-operated, stored pressure, cartridge-operated.
Different mechanisms.
Yeah. The extinguishing agent, they contain water, foam, dry powder, CO2, wet chemical. Yeah. The type of nozzle, their construction, how to operate them correctly, maintain them, and the proper procedures for refilling them after use or periodically.
So a really thorough grounding in the science of fire itself and the tools and techniques used to combat it based on that science.
That's the idea. Understand the why before the how.
Okay, great. Now let's move on to something that sounds entirely practical. Firefighting drills.
Yeah.
This is all about putting that knowledge into action, right?
Absolutely. Practice, practice, practice.
Yeah.
This section of the curriculum is focused entirely on practical training and developing muscle memory.
Muscle memory, yeah.
It outlines various types of extinguisher drills for all those different kinds we just mentioned: water, CO2, chemical foam, mechanical foam, stored pressure water, dry chemical powder, ABC multi-purpose extinguishers, often mentioning standard sizes like 9 liters for liquid types or 5 to 10 kilograms for powders or CO2. The key here isn't just knowing about the extinguisher, but being able to grab the right one, activate it, and use it quickly and effectively under pressure without fumbling.
So it's about making the correct actions almost automatic, knowing exactly what to do without having to stop and think too much when seconds count.
Precisely. You drill it until it's second nature, and then there are the hoses, which are fundamental for getting larger amounts of water to a fire.
Yeah.
Lots of drills there. Yes, it details various hose drills, things like pickup drills for quickly connecting hoses together or to a hydrant, and running drills laying out 1, 2, or sometimes 3 lengths of hose efficiently, emphasizing speed and teamwork.
Getting the water pathway established fast.
Exactly. Then it covers specific hydrant drills. Everything from opening and closing the hydrant and the hose lines properly and safely to techniques for safely changing a burst section of hose while the line is still potentially under pressure. Can be. Increasing or decreasing the length of the hose line as needed. Using and disconnecting specialized fittings called collecting breechings, which combine multiple smaller hoses into one larger one. And dividing breechings, which split one large hose into multiple smaller ones. Plus, the correct techniques for handling different types of hose branches or nozzles at the business end, controlling that water stream effectively.
It sounds like a very systematic way to learn how to deploy and manage hydrants and hoses effectively in all sorts of different scenarios.
It has to be systematic.
Yeah.
And ladders, of course, are often essential for access, for rescue, for getting water into upper floors.
Right.
The curriculum includes comprehensive ladder drills, covering the techniques for pitching that's setting up ladders safely and efficiently against a building.
Pitching. Okay.
Climbing with the proper technique, using a leg lock for stability if you need to work hands-free at height.
Securing yourself.
Exactly. And even practicing the fireman's lift or carry for rescuing injured or unconscious individuals down a ladder.
Wow.
It also includes essential familiarization with breathing apparatus BA sets, critical piece of kit,
Absolutely. For smoky environments.
or toxic ones, including the correct procedures for donning them quickly and ensuring a good seal, practicing moving and working, maybe even running, while wearing them in simulated emergency conditions.
Getting used to the weight and restricted vision.
Exactly. And even practicing specific rescue techniques, like navigating through a confined space or a simulated collapse structure or tunnel while wearing BA.
And it's not just about fighting the fire itself, is it? Providing immediate medical assistance is also critical in many emergencies.
Oh, absolutely. Firefighters are often the first medically trained people on scene. So this part of the curriculum covers first aid in detail.
Like what?
Studying the contents of a standard first aid box, practicing stretcher drills for moving casualties safely, performing those fireman's lift carries again, applying various bandaging techniques for different injuries, standard ambulance transfer drills, CPR techniques, vital skill,
Yep.
how to assist someone who is choking, maybe older techniques like Schaffer's method of artificial respiration for context, practicing various rescue carries, and performing mouth-to-mouth resuscitation. It highlights that firefighters need to be competent first responders with crucial medical skills.
So a really well-rounded approach to emergency response, covering both fire suppression, rescue, and immediate medical care, that's comprehensive.
It has to be. You never know exactly what you'll face.
Okay, now let's move on to fire technology. How is this different from, say, fire engineering science? It sounds similar.
It is related, but fire technology seems to encompass a slightly broader view, perhaps focusing more on the equipment and systems themselves, building on the science. It revisits some of the foundational science, yes, like the nature of fire, changes of state, latent heat, thermal expansion, all crucial for understanding fire behavior and how equipment interacts with it. It discusses heat transmission again, combustion, the fire tetrahedron, different types of combustible materials.
Reinforcing the basics.
Exactly.
Yeah.
It reiterates fire classification and the various methods of extinguishing different types of fires, and takes another, maybe more detailed look at portable fire extinguishers and their operation. It's about solidifying that theoretical knowledge, but with a very strong focus on the practical application and the tech involved.
So it's building on that earlier science, but with a more direct focus on how it relates specifically to the firefighting tools and tactics and the technology behind them.
I think that's a good way to see it.
Mhm.
And hydraulics, for instance, are obviously fundamental to moving water effectively in firefighting operations. That gets covered here too. Yes, this section covers the fundamental principles of hydraulics that are essential for firefighters to understand. Things like atmospheric pressure, the concept of suction lift, how a pump can draw water up from a source below it,
Right.
and how to calculate nozzle discharges, how much water is flowing at what pressure. It discusses the pros and cons of centrifugal pumps, which are common in fire engines, the different types of pumps and priming methods used, getting the air out so water can flow.
Ah,
Yeah, crucial step. And the correct procedures for operating these pumps under various conditions. It also delves into the various types of ladders and trolleys used by fire services, techniques for safely pitching and climbing them again, the importance of their maintenance, and even design considerations for specialized vehicles like turntable ladders, the big aerial platforms, and water tenders or tankers.
so a real deep dive into the machinery and the engineering behind modern firefighting capabilities. What about getting water to where it's needed, especially in situations where the fire is maybe far from a hydrant or a water
All
source?
right, that's where water relay systems become critical. The curriculum covers the different types and arrangements of these systems.
What does that involve?
It usually involves using multiple fire engines and pumps connected by long stretches of hose to move large volumes of water over significant distances, maybe uphill, pumping water from one issue to the next.
A chain of pumps.
Essentially, yes.
Oh.
It also discusses the properties and capacity of various types of hoses, ropes, lines, and knots used in firefighting, different materials, pressure ratings,
Uh-huh.
as well as the function of hose reels and fittings, the different types and construction of fire hoses, their proper maintenance inspecting, cleaning, drying, the use of drying cabinets, and how to perform field repairs if needed. The seemingly simple fire hose is actually quite a sophisticated piece of technology that requires careful handling and maintenance.
It's easy to take it for granted, but yeah, it's crucial. It's all about the practicalities of getting the right equipment to the right place and keeping it in perfect working order.
Mm.
And there are so many different specialized fittings involved in connecting all these hoses and pumps together.
Indeed. This part of the diploma details various hose fittings, things like branches for splitting water flow, different types of nozzles for creating different stream patterns, solid jet, spray, fog,
Right.
collecting heads for combining water sources into one hose, suction fittings for drafting water from open sources like rivers or ponds, stand pipes for accessing water risers inside buildings, adapters for connecting hoses or fittings of different sizes or threads.
Compatibility issues.
Exactly. And various miscellaneous other fittings, as well as essential items like hose clamps for temporary leak control and strainers to prevent debris entering the pump. And again, the crucial aspect of maintaining all these fittings.
Always maintenance.
Always. It also covers the use of foam as an extinguishing agent in more detail here. Different types of synthetic foam concentrates, the methods for achieving the correct concentration, usually 3% or 6%, and inducting the foam concentrate into the water stream using specialized equipment.
Making the foam solution.
Right. Various types of foam-making equipment or nozzles and things like pressure control valves for managing water flow accurately, which is important for foam proportioning.
Foam is such a versatile tool, isn't it? Especially for tackling certain types of fires, like those involving flammable liquids where water alone might not be effective or could even make things worse.
Absolutely. It forms a blanket, cutting off the oxygen supply. And of course, none of this matters if the firefighters themselves aren't protected. So, personal protective equipment is key. Absolutely. The curriculum includes detailed technical descriptions and specifications for fire protective clothing, the bunker gear, ensuring it meets stringent safety standards for heat resistance, water resistance, breathability, etc. It also covers the different types of breathing apparatus used in hazardous atmospheres again, their proper care and maintenance routines to ensure they function reliably every single time.
Can't fail.
Cannot fail. The system of lifeline signals, rope signals used for communication between firefighters inside a building and those outside, especially in low visibility conditions,
Simple but effective comms.
can be life-saving. Various small but essential gears and hand tools, axes, Halligan bars, hooks, lighting, thermal imaging cameras, both conventional and non-conventional, powered and non-powered tools along with their proper maintenance. The personal protective equipment and the tools are literally a firefighter's lifeline.
It's just a huge array of specialized equipment that firefighters need to be completely proficient with and know how to maintain meticulously. And this section, fire technology, really seems to emphasize the hands-on aspect of learning all this, doesn't it?
Yes, it specifically mentions a wide range of practical exercises designed to build that proficiency, including wet drills actually flowing water and dry drills using different types of nozzles.
Okay.
Identifying and practicing the use of all those portable extinguishers we talked about, learning how to properly fill or recharge extinguishers, correctly donning and working in full protective clothing.
Getting comfortable in the gear.
Exactly. Conducting realistic mock fire drills, simulating different scenarios, practicing ladder positioning and climbing again, demonstrating the use of various ropes, lines, and knots for rescue or securing equipment,
Yeah.
practicing different hose laying and rolling techniques for speed and efficiency, pump priming procedures, conducting full-scale hydrant fire drills, and even visiting real-world sites like industrial plants or high-rise buildings to reinforce the learning in a practical context.
All that hands-on experience, it really must be what truly bridges the gap between reading about it in a book or hearing about it and being able to actually do it effectively in a real-world, high-stress situation.
It's absolutely indispensable. You learn by doing, especially in this field.
And finally, just to round it off, we have practical and viva. This sounds like the final exam, essentially.
Pretty much. This final component is the ultimate assessment. It's where students have to demonstrate their practical skills, performing tasks in realistic scenarios under observation.
Show what you know.
Exactly. And also demonstrate their theoretical understanding through a viva voce examination, an oral exam, where they answer questions and discuss concepts. It's where they have to show they can integrate all the different aspects of the curriculum, the science, the technology, the procedures, the safety management, pull it all together.
So looking back at everything we've covered, this diploma in fire technology and safety management, it really does provide an incredibly comprehensive education, doesn't it?
It really does.
Covering everything from the fundamental science of fire itself right through to the intricate details of designing and maintaining fire protection systems, understanding industrial hazards, and mastering the essential hands-on skills needed to respond effectively and safely in any emergency.
Yeah, it connects all the dots.
It's crystal clear that understanding these principles is just crucial for anyone involved in ensuring safety and preparedness, whether it's in a workplace, a public building, or even just being more aware in daily life.
Absolutely. And what's really striking, I think, is how a deeper understanding of even just one of these specific areas, say, the nuances of different fire detection technologies we discussed, or the strategic planning that goes into effective emergency evacuations,
Mm-hmm.
how mastering just one piece can have such a profound positive impact on safety outcomes in all sorts of different settings, from a small business to a major industrial complex.
That's a great point. It really makes you consider the specific applications of this knowledge, doesn't it? And maybe which of these diverse topics, the management systems, the engineering, the science, the practical drills you personally find most compelling or relevant.
Exactly. There's so much depth in each area.
Absolutely. Well, consider this deep dive into the DFTSM curriculum just a starting point. We really encourage you, the listener, to think about which specific aspects of fire safety and technology sparked your curiosity today, and maybe consider exploring those further.
There's always more to learn.
Always. Thanks for joining us on the deep dive.